7th graders. Today we are multiplying decimals. So multiplying decimals is a two-step plan. Step 1, multiply like no one ever invented decimals. Step 2 is count the number of decimals in the problem that are on the right of the decimal points. So I'm going to quick go through and just plow through step 1 on every problem. Multiply like decimals never existed. 7 times 8 is 56. 4 times 8 is 32. 8 times 5 is 40. 2 times 3 is 6. 8 times 7 is 56. This I'll do it out for you, even though I can do that one now. But anyway, so we're going to go 40. Gets me a 9. That's a 0. 54. 630. If we ignored the decimals, that's what we have. This would have a 66. And another indented 66 to get 726. So how you start them all, you just ignore the decimals, like no one ever invented decimals, you never heard of decimals, just multiply the basic numbers, ignore all the zeros, just multiply. Then after you do that, step 2, you have to count in the problem all the stuff that's on the right of the decimals. So 7's on the right, 8 is on the right, there's 2 numbers there that are on the right. So in our answer, we need 2 numbers to be on the right of the decimal. The only way we're going to do that is by putting the decimal right here. Count this way, those 2 positions, always from the end back toward the beginning. Count 2 positions, and that helps us count the 2. So 1, 2 in the problem, 2 in the answer. This, we have a 2 and a 3 again. They both count because both numbers are on the right of the decimal. So down here, we need a count of 2. So moving from the end back to the beginning to make a count of 2, the decimal has to go all the way left, and then we end up having to fill a gap with a 0. The decimal will not always end up at the beginning, so don't be misinformed by that. So let me show you one where the decimal's in the middle. On this, the 8 doesn't count because it's not anywhere near a decimal point. Only the 7 counts, so we only count to 1. So if the decimal goes here, we're making that answer count to 1 because there's 1 number on the right. This, we've got a crazy count up to 7. 1, 2, 3, 4, 5, 6, 7 numbers that came on the right of the decimal point. So to make this count to 7, we're going to need a whole bunch of stuff to even make 7 spaces. So we start at the end, we work back toward the beginning. We're going to need to do a string of 5 zeros to make there even be 7 items. And then the decimal does go, in this case, all the way at the beginning. Often the decimal does go all the way to the beginning, but sometimes it goes in the middle. You just have to count. With this, we're doing a count of 4. These 2 count. These 2 count. If we want to try to make 4 of them and the answer count, start at the end, work your way back toward the beginning. The decimal's going to end up at the beginning, as it often does, but we can't count to 4 unless we get a couple extra zeros in that one. I'm not happy with that answer completely, but I'll be back. This one, we have a count of 3. 1 does not count. 8 does because it's on the right. 3 and 5 count because they're on the right. So 1, 2, 3 count. I have 3 numbers, beautiful, it works. I'm going to go decimal at the beginning, but I'll criticize that for the same reason. This, we also have a count of 3. I'm going to change the problem just for variety. If the original problem had been this, I'm going to only have a count now of 2. This doesn't count, so it's on the left. This doesn't count, it's on the left. Those 2 on the right count, so a count of 2. We always start at the end to do our count of 2. Decimal has to go there. By now, some of you might have remembered why I was criticizing them. If you ask yourself, why is he criticizing those answers? When we seemingly are done, look around. And if there's any zeros at the very end, we do not want them anymore. Don't make that change until the very, very end, because that would mess up your count. Because now the counting scheme is somewhat mismatched. But these are now, after the erasure, considered better answers. We do want to do that, but not until the last step. So that's what we're doing. Thank you.